is our introduction to acids and bases. There are many classifications of acids and many different definitions. Some types of acids are traditional acids, Bronsted acids, and Lewis acids. Bases are categorized as weak or strong, depending on their pH level and how they react with acids mentioned earlier. According to Arrhenius, acids are compounds that contain hydrogen and can dissolve in water to release hydrogen ions into solution. For example, HCl plus NaOH yields H2O plus NaCl. The hydrochloric acid reacts with the sodium hydroxide to yield water and sodium chloride, or another word for table salt. As Arrhenius implies, the hydrochloric acid breaks down in the water and separates into water and a salt. Another example is HBr plus KOH yields H2O plus KBr. Which compound is being dissolved in this chemical equation? What kind of reaction is this? The properties of acids: sour taste, corrosive against metals, pH level under 7, turns litmus paper red. Acids are used in common things that we encounter on a daily basis, such as vinegar, urine, lemons, and oranges. Many household cleaners contain acids and multiple over-the-counter painkillers. Some common acids that we all know are sulfuric acid, nitric acid, hydrochloric acid, and acetic acid, all of which are very corrosive and dangerous for laboratory use. Acids can be highly dangerous depending on their molarity content. The higher the molarity, the stronger they are. Some acids have been known to eat through clothing and even human flesh by burning it. Acids used in the laboratory are usually about 1 molarity strength. A base is a substance that can be gained hydrogen ions or protons in a chemical reaction. Bases are often referred to as alkanines. Alkalines are a solution that contains hydroxide ions from a soluble base. For example, NaOH yields Na ion plus OH ion. When sodium ionizes, the sodium ion and oxygen ion split, and we end up with a sodium ion that's positive and a hydroxide ion that's negative. Properties of a base: bitter taste, slippery feel, change litmus paper from red to blue, reacts with acid to produce salt and water, and electrolytes. There are different types of bases that depend on how strong or weak the base is. For example, a base that is strong electrolyte or a strong conductor of electricity are a strong base. These are often the active metals of groups 1 and 2 on the periodic table. Ionic hydroxides are a type of base that are aqueous in alkaline solutions. Bronsted bases are a type of base that produce hydroxide ions after taking protons from water molecules. Water-soluble bases are weak bases because they are weak electrolytes. There are 3 familiar acid-base reactions: neutralization, Bronsted acid base reactions, and Lewis acid base reactions. Neutralization is a reaction by hydroxide ions to create water molecules and salt. A Bronsted base is a molecule or ion that accepts protons. During Bronsted acid base reactions, the protons are transferred from the acid, which is the reactant, to the base, which is the other reactant. A Lewis base is an atom, ion, or molecule that is considered an electron pair donor. During a Lewis acid base reaction, 1 or more covalent bonds form between an electron pair donor and an electron pair acceptor.
This is our demonstration video on acids and bases. After you guys watch the video, we'll go over what happened.
This is our demo on acids and bases with 0.1 molar hydrochloric acid and 0.1 molar sodium hydroxide. We will also include water in this demo. We will use a universal indicator to identify the pH levels of the solution. The color that the indicator creates will indicate whether the solution is an acid or base. Pay attention to this. It will be used in the mini lab you do later on. Enjoy.
Alright, so in this demonstration we'll use 3 Erlenmeyer flasks. I'll put the indicator into each solution and that'll identify whether it's neutral, acid, or base. Put a few drops of each. Okay, so as we can see, NaOH has more of a purple hue, water, green, and HCl has more of a pink color. So as you can see from each of these, the red is going to indicate an acid, the darker color, purple, would indicate a base, and the green is going to indicate neutral. Okay, so now I'm going to take the two solutions, HCl and NaOH, and we're going to mix them together. So when you combine them, try not to put too much in. You may begin to see that it will balance out. I'm going to try to do this carefully. Should get green like the water. Now as I pour these in, you can see which one is the limiting reactant, from which color changes and which color stays the same. I'm going to use the dropper. So HCl is in excess right now, and we're slowly going to drop sodium hydroxide in until the color changes. A little bit more than that. There we are. So now, what kind of reaction is this? Think about it for a minute. Okay, so if you haven't gotten it already, it's a double placement reaction. We're taking hydrochloric acid, sodium hydroxide, and changing the two to produce salt and water, as you can see here. And that concludes our demo. So please use the information in this demonstration to assist you in the mini lab we do later on. Bye guys. Okay guys, so in our demo we mixed hydrochloric acid and sodium hydroxide to form salt and water. And that was a double placement reaction. And that's not an acid-base reaction, it's a chemical reaction. Which is important for what Crystal is about to explain.
The type of acid-base reaction that formed during the demo was called neutralization. Because the acid and the base work together to form a neutral solution, which is basically water.
So in conclusion, acids, they have a sour taste. Some of them, most of them are corrosive. Found in daily items like lemons and household cleaners. And they're found in medication. And bases, they have a bitter taste. They're slippery, they have electrolytes, and they're often used for laboratory use.
In the mini activity, you will be determining if common everyday objects are acids or bases by comparing their pH levels to a pH chart we provide. In addition, you will answer questions based on our lesson.
We chose the topic acids and bases because we have background knowledge from biology with Mr. Mahar. After doing research on multiple demonstrations, we chose our demonstration because we felt it clearly explained our topic. We created our mini activity with the goal to test the students on what they learned and took away from our lesson. We came up with the idea of a voiceover because we felt it was the best way to display our information, some challenges we faced. We're trying to work around our schedules, technology problems, putting it all together and agreeing on a topic. So this is our lesson. Hope you enjoyed it. Hope you learned something. I'm Keegan.
I'm Crystal.
I'm Jake.
Bye.